In this video, we're going to discuss the basics of probability, which are counting, combinations, and permutations. So the first thing I want to talk about is using sets in a Venn diagram. So a set is just a way to organize numbers or a collection of things. And you've probably seen a Venn diagram before. It's probably been a little while, but it's a way to organize sets of information that overlap with one another. It's a great visual tool. It's one of my favorites. So let's actually take a look at an example. So let's say a vet surveys 26 of his customers. He discovers that 14 of them have dogs, 10 have cats, 5 have fish, 4 have dogs and cats, 3 have dogs and fish, and 1 has both a cat and a fish. If not one of them has all 3 kinds of pets, how many of these have none? One way to approach this problem is to use a Venn diagram. So I like to set it up with naming my 3 circles. So I have 3 circles because I'm going to be talking about dogs, cats, and fish. So I'm told that 14 total have dogs, 10 total have cats, and 5 total have fish, which means that everything in this circle is going to add up to 14, everything here is going to add up to 10, and everything here is going to add up to 5. So let's start figuring out more of our information. Now, 4 have dogs and cats, so this kind of not circle shape here is going to have 4. So in here is going to add up to 4. 3 have dogs and fish, so 3 is going to go in there. And then 1 has a cat and a fish. How they do that, I don't know. But the one number that I do know for sure is that no one has all 3 kinds of pets. So there is nobody in here. And what I could do in between is figure out that, all right, if this thing adds to 3, 0 plus what gives me 3? So that's going to be 3 in here. And then I can figure this out to be 4 and this in here to be 1, which, given this information up here and down there, I can figure out the rest of these circles. So if 4 and 3 make 7, the remainder is going to be 7 in here. And if 4 and 1 make 5, the remainder is going to be 5. And if 3 and 1 make 4, the remainder is going to be 1 in here. So I've been asked how many of these 26 patrons don't have a dog, a cat, or a fish. So what I'm going to do is I'm going to add up each of these numbers and subtract it from 26 to find my answer. So I added them all up and I got 21. So that means that there's a total of 21 patrons represented here. And of the 26, which you could actually start by writing up in our universal set or our box, of the 26, that means that 5 of them don't have any of those pets. All right, let's talk about some definitions. The first one being the fundamental principle of counting, which is also known as the multiplication rule for counting in probability. So essentially what that gives us is the total number of combinations possible for whatever parameters I give it. So what that means is that I'm going to multiply each option that I have by the next one, and that will give me the total number. So it's like counting, but a lot faster using multiplication. The next 2 are combinations and permutations. So these are like brothers in probability. They're very related, but they have one really big difference. The first thing to know is that it has this notation, and it has a C for combination and a P for permutation, but they both have a little n and a little r. It starts with the n, ends with the r. The n represents the total number of options available to you. And so that could be like the total number of socks you have in a drawer or the total number of things in your fridge to make a sandwich from. And then r is what we are trying to choose. So maybe I'm only looking for green pairs of socks, or I'm only looking to make a turkey sandwich. Those are the things that I'm choosing out of all of the options that I have. So another way to set it up, you have these parentheses here for combinations, and really you want to look at this one for combinations, where n is that first number, you take the factorial of it and you put it over the r, and then you have the factorial there, and then the difference between those two, and you bring that to a factorial. That will give you the combination. Permutation, same thing, except it doesn't have this r at the bottom. So besides the fact that their equations are slightly different, the big difference between combinations and permutations is that with a combination, the order doesn't matter. So whatever you're picking, maybe it's the types of socks that you're taking out of the drawer. Doesn't matter if it goes green, red, blue. But with a permutation, the order matters. So let's look at a couple differences here. Now, a permutation, you would have a team where it matters who goes where, and picking colors in order, picking first, second, third place. Combinations, doesn't matter. I'm just going to pick 3 people. Gonna pick 2 colors. Gonna pick 3 winners. So combinations are way less picky than a permutation. Let's do a few quick examples. So this is a family restaurant breakfast special menu, and I need to figure out what I want to eat. So question A asks me, how many different breakfast specials are possible if I pick 1 breakfast sandwich, 1 accompaniment, and 1 juice? So the way that I could do that is using the counting principle. I have 3 options here, I have 4 options here, and I have 5 options here. The way that this works is you just multiply them all together. And all that says is that I have 60 different combinations that are possible to me. So B asked me how many different breakfast specials without meat are possible. So the only breakfast sandwich that's going to work for me is egg and cheese. So really that limits me to 1, but all my accompaniments are still the same. So really, if you're a vegetarian, you only have 20 combinations possible, which is fine. Next example. A coach must choose 5 starters from a team of 12 players. How many different ways can the coach choose the starters? So what I'm really going to ask myself here is, do I need the counting principle, combinations, or permutations? So if I'm choosing 5 out of 12, to me that says either combination or permutation. Now, the next thing I ask myself is, does the order matter? And in this case, it doesn't. So I'm going to use combinations for this. And the way that I set that up is, I write my big C. Of the players I have to choose from, I have 12, and I'm going to pick 5 of them. So I can use my calculator to do this, or I can write it out, where 12 factorial is going to go on top. The 12 minus 5 will be its own factorial, and the 5 will be its own factorial. So let's write this out. All right, so when you get really good at this, you won't have to write all of this out, but what I notice is that this is the same as this. So I'm going to start cross-canceling here. 5 times 2 is the same as 10, and 4 goes into 8 twice, 3 goes into 9 3 times, and the 1 I can just get rid of. So that's really 12 times 11 times 3 times 2, which is 792 possible combinations of 5 players from a 12-player team. Last example. So how many different ways are there to arrange the letters M-A-T-H to spell a new quote-unquote word if each letter is used only once? So there are 2 ways that we can approach this. The first, I'm actually going to use a permutation because the order does matter when I spell out this word, or word. So what I can do is I can set this up with my P, and I have 4 to pick from, and because I'm going to be using all 4 letters, I'm going to do that. So that's going to look like 4 factorial over 4 minus 4 factorial. So that's 4 times 3 times 2 times 1 all over 0 factorial, which is 1. So that's going to give me 24 different combinations. Another way to look at this is I know that I have 4 possible spots here to spell out this word. And if I start with my first letter, I have 4 to choose from, M, A, T, and H. So that gives me 4. Then I eliminate one of those, and I have 3 options left. After that, I have 2 options left, and whatever's left, I only have 1. So that's our counting principle at work, and that also gives me 24. And that's going to do it for this video. Thanks for watching.